How do many concurrent JavaScript promises impact performance? Have you ever wondered how running multiple JavaScript promises at the same time affects your application's performance? Let's break it down in a simple way. When you have many promises running concurrently, they execute asynchronously. However, it is important to note that JavaScript operates on a single thread. This means that while promises can start their tasks almost at the same time, they do not run in true parallel fashion. This concurrency allows tasks to overlap. For example, if one promise is waiting for a network response, JavaScript can continue executing other code. This is a great way to use waiting times effectively. But there is a catch. When you start too many promises at once, it can lead to performance issues. First, consider resource usage. Each promise may involve different operations like network calls or file access. If you start many promises simultaneously, it can overwhelm your system resources. This might slow down all operations or even cause failures. Next, let's talk about the event loop and task queue. Promises relying on the event loop to manage their resolution callbacks. When you have many promises running at the same time, it increases the number of tasks waiting to be executed. This can delay other JavaScript code and user interface updates, making your application feel less responsive. Another important factor is error handling. When many promises are running, managing their results and errors can become tricky. For instance, if you use the method called promiseAll, it will reject immediately if any single promise fails. Meanwhile, the other promises continue to run in the background, which can lead to unexpected results if not handled correctly. To avoid these performance issues, developers often limit the number of concurrent promises. Techniques like batching or throttling can help balance the workload. This way, you can prevent overwhelming your system while still getting the benefits of concurrency. In practical web development, knowing how to manage these impacts is essential for writing efficient asynchronous code. Using methods like promiseAll, promiseAllSettled, promiseRace, and promiseAny can help you control how promises run and how their results are processed. For example, promiseAll starts all promises at once and waits for all of them to resolve, which is efficient but can be resource-heavy if you have a large number of promises. In summary, while having many concurrent JavaScript promises can improve performance by allowing tasks to overlap, too much concurrency can strain your resources and affect how responsive your application feels. Managing concurrency effectively is key to mastering asynchronous JavaScript and creating smooth web applications.